When we learn about quantum numbers, we learn that atoms are going to be particularly stable when they have 8 electrons in their outermost n level. So in their, for example, 4s and 4p, they get the stability when they look like the noble gas because they have 8 electrons. Well, let's look at this example. Bromine is going to be argon on the inner shell. It's going to be a 4s2, 3d10, 4p5. So we're going to have 7 electrons in our uppermost n level. That means we're 1 electron away from having a full octet. So it ideally will grab one more electron and end up being very energetically stable as a result. Now, a Lewis dot structure is a quick way to visualize that and to determine if a bond will be ionic or covalent. Now, here's what you'll be able to do, and I'd like you to pause the video and go ahead and fill this one in right now. Go ahead and write your orbital and your condensed orbital notation for oxygen atomic number 8. Okay, atomic number 8, it's currently neutral. That means it has 8 electrons to place. We have 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 electrons. That tells us that our condensed electron notation is going to be helium on the inner shell, the 1s orbital. Then we're going to have our 2s at 2. We're going to have our 2p at 4. So this will be our condensed notation for the oxygen atom. Now, all we care about in this, though, for what we're about to do, is going to be the outermost electrons. So this is going to have 6 outermost electrons. So what we'll do is we'll go ahead and we'll write oxygen down. We're going to place one electron in around that atom at a time. So we'll do 1, 2, 3, 4. I've still got 2 more electrons to place to get up to that 6. I can put them absolutely anywhere I want. I can put one right there and one right there. One reason I might do something like that is if I expect I'm going to have another atom come in from the side and dock with it in order to share and make a pair. So that'll be how we do these. We start unpaired for 1 through 4, then we pair up for 5, 6, 7, and 8. Just as a quick example, 1, 2, 3, 4, 5, 6, 7, and 8. And you can see that I just went wherever I wanted each time. You do your first 4, then you do your second 4. That's how we'll be able to do a Lewis dot structure for these. Now, when we start having multiple atoms, we'll be able to bring them closer together. So let's do a Lewis dot structure for hydrogen. Hydrogen has 1 electron, and hydrogen here will also have 1 electron. Notice what's going to happen if we bring them close together. We're going to be able to share 1 electron from over there and 1 electron from over here. Same thing over on this side. And as a result, if they start sharing the electrons, oxygen will feel like it's got 8 electrons. Hydrogen will feel like it's got a duet, an octet basically. It'll have its 2 electrons that fill up its 1s orbital. That's the kind of thing that we're doing. This is also the starting point for where we're going to start thinking about bonding, and it's also one of the reasons that water ends up being so stable, you know, H2O.